Good morning, friends. In today's video, we are going to work out a problem on the section of a square pyramid. And the question for today's video reads like this. A square pyramid of side of base 40 mm and axis 60 mm resting on its base on HP with an edge of the base normal to VP. So we'll write down the initial position of the solid and then we can proceed with the cutting plane. So we have here a square pyramid resting on its base on HP. So write down the top view of the square pyramid, that is a square having the sides measuring 40 millimeter is the side. So I'll write down here SQ 40 means the side of that is 40 millimeter. All the sides will measure 40. We'll join the diagonals of this so that we get to O, the vertex, and we'll number this as A, B, C, D. This is A, B, C, and D. O is the apex or the vertex of the solid. O comma O1 will write down. O1 is the center of the base. O is the vertex of the solid. So we'll project all these points onto the XY line and obtain the corresponding front view of the solid. This is how the solid will look. We'll join this to this point to this. We'll call this as O dash, and this point is A dash, B dash. This is C dash, D dash. Here AB is one of the side that is perpendicular to VP as per the question given. O1 dash is the center of the bottom face. A dash, B dash, C dash, D dash is the base of the solid. This is how the pyramid looks in the front and top views. The height of this is given to be 60 millimeters. So I will take this height as 60 millimeters. That is from O dash to O1 dash. This is the XY line, VP and HP we have written. Friends, the pyramid in this question is cut by a section plane which is normal to VP, perpendicular to VP and inclined to HP, such that the true shape of the section or the true shape is a trapezium. Trapezium will have two parallel sides and a distance between them. And he says that trapezium is going to have 40 millimeter and 20 millimeter as the dimensions of the parallel sides of the trapezium. Friends, here is a clear indication, since it has got the dimension of 40 mm and the base is also 40, the section plane should necessarily pass through one of the base edges, either AB or CD. And what angle we do not know. But he says when it is cutting at an angle to HP, the true shape you are going to get is going to be a trapezium. So friends, in the top view, you will have 4 points, 2 passing through this A and B and 2 on this. That is, the section plane which is normal to VP inclined to HP passes through AB, which will give the dimension 40 mm, and somewhere on OC and OD you will have 2 more points and the distance between them is to be necessarily 20. This is 20, this is 30. And when you just cut this solid and throw away the upper piece, you will be seeing in the true shape a trapezium. So friends, what we can do here? I can take A as a point, B as a point. AB is one of the parallel side of the trapezium because it has to have the dimension 40. same as that. If it were 30, we would have taken, say, from here, some distance, 30 here. And the parallel side should have the dimension that is 20. So first I will mark here 40. 40 millimeter is this side AB of the trapezium in the true shape. And on CD, it should be 20. How to mark the 20 mm here? Friends, you can just write a line, a horizontal line through the center. Mark anywhere on that distance equal to 20 mm. That is 10 mm on both the sides. Extend that to this line. So you are going to have a point here, another point here. So totally you are going to have 1, 2, 3 and 4. This is going to be the top view of the trapezium. So friends, I am going to join all these 4 points, these 2 and these, by straight lines, and I am going to hatch it, indicating this is the sectional top view, complete sectional top view. Friends, if you mark these points as 1 and 2, 1 and 2 will measure 40, and this, if you mark it as 3 and 4, this 3 and 4 distance will be equal to 20, because you have taken that distance as 20. If it were 30, I would have taken 15, 15 on either side. Friends, this complete figure will give you sectional top view. Now friends, it's a reverse process. We have marked the sectional top view, and now we have to obtain the position of the section plane. How does this appear, friends? See here, from this point, point 3 and 4 are on OC and OD. What I do, I extend this line upward. From here, extend it upward, and it is going to meet or cut OC and OD at this point. A and B are cut here, OC and OD are cut here. So these are the two slant edges. This is the edge of the base. Friends, I am going to join these 2 points. Join these 2 points and extend. And friends, this will give you the section plane SS, which is cutting the solid. So friends, this is going to be points on that 3, 4, and this is 1, 2. This point is 1, 2. So friends, after you have got the front view and the sectional top view, we can obtain the true shape of the section, which is given to be a trapezium. So what is the procedure, friends? Now we are going to retain this much portion of the solid. This is the solid that is retained. To obtain the true shape of this section, we are going to write a line parallel to SS at any convenient distance. So this line I have drawn here is parallel to SS, the section plane, at any convenient distance. Friends, we are going to draw perpendicular lines from these 3, 4 and 1 and 2 perpendicular to this. So friends, say this is one line which is perpendicular. This is the second line which is perpendicular, and here we should get the true shape of the section. Friends, always for drawing or to obtain the true shape of any solid, the procedure is very simple. We locate these points 1, 2, 3 and 4 on these lines with this reference. Say this is x1, y1, some reference line. Friends, here point 1 is this distance, this much distance from x. Why? So I am going to take this distance and mark on this line as point 1. And friends, next 2 is here. Distance from xy to 2 is to be marked here. So here I am going to mark point number 2. Then friends, 3 from xy to this point is 3. And similarly point 4 from here to xy, we are going to take this distance. Friends, we have got all the 4 points 1, 2, 3, and 4. Join the points so obtained by straight lines like this. So I have joined 1 to 2, 2 to 3, 3 to 4, and 4 to 1, and hatch it or section it by lines drawn at an angle of 45 degrees to the horizontal. And friends, you can observe here the distance between 1 and 2 is this distance. It is nothing but 40. And the distance between 3 and 4 is 20. So this is 3 and 4 is 20. And this figure is the true shape of section TS, true shape. And this is very obviously is a trapezium. And friends, after completing this figure, we have got the sectional top view here. This is the front view, and I will mark it as FV. This is the true shape of the section. Friends, after completion of this problem, you will be able to find out what is the inclination of this section plane with HP. So you can measure what is the angle made by the section plane while cutting this cone. That can be measured. And friends, they might also ask you to measure what is the distance between these parallel edges or the height of the trapezium. Even this can be measured. Friends, I hope the presentation was interesting. Please go through the complete video, and in case you are not subscribed to my channel till now, please don't forget to subscribe and share this information about my videos, that is engineering drawing by Dr. M.H. Annaya, to all your friends and relatives. So have a wonderful day. Thank you very much for watching my YouTube video.